Welcome to this video, dear learners. So here in this video we'll simply be answering some questions in section B. This is a paper that was a GCE paper for science, okay, 2023. Okay, so we'll start with section B, which requires us more time. I would have started with section A, but then I thought let me start with section B. Okay, so this was made by it was a request made by some learners that I should go through this question paper. So let's go through it together. So as you can see there, question B1 says that a learner carried out an experiment and obtained the following results as shown. It says, where necessary, take the density of water to be 1 gram per cubic centimeter. Okay, so that's what the question says. And the mass of an empty bottle is 8 grams. The mass of a bottle full of water is 20 grams. The mass of the bottle full of liquid X is 20 grams. Okay, so now we are on question B1 and we're answering question what? A. Okay, so name the instrument that can be used to obtain the results of mass. Okay, so we know the instruments that we use when measuring them. Okay, so we have a beam balance. We can use a beam balance. You can measure the mass. Okay, so an instrument can be used to measure the mass. Okay, a beam balance. Okay, beam balance is used to measure mass. Okay, also those laboratory scales can also be used. Okay, they're somewhat like this. Okay, and you simply need to put something here and then you can read the mass there. Okay, then we go to question B. Calculate the volume of the bottle. Okay, so the volume of the bottle. So now the volume of the bottle, what we can do is this. We have the mass. So let's look at first. We want to measure the volume, okay, of the bottle. So what we want is volume. Okay, volume of what? The bottle. Okay, so looking at the things that we have been given here, we know the formula for volume. Okay, first we'll do density is equals to mass over volume. If we change the subject of the formula here, we do this. So you have dV is equals to m. So over d over d. Okay, and here we get V is equals to m over what? Over di. Okay, so the volume of the bottle, we need the mass of the bottle, and also we are going to need what? The density. Okay, we're going to also need the density of the bottle. Okay, so now here we're not talking about because here Elena carried out an experiment and obtained the following results as shown. Okay, where I take the density of water to be that. So first here we have the mass of the bottle, which is 8 grams, and the mass of the bottle of water is what? 20 grams. Then the mass of the bottle full of liquid X is 20. So to find the volume of the bottle, we need simply to find the volume of the water. Why? Because water is a liquid and it will take up. So the volume of water equals the volume of the bottle. Okay, I hope you understand. So the volume of the water here will equal the volume of the bottle. Okay, so using this formula, we're going to say volume is equal to, now what is the volume of water? Okay, or what is the mass of water? So mass of water is simply going to say mass of both what? Bottle and water. Mass of both bottle and water is 20 grams. Then mass of bottle alone is 80 grams. So to find mass of water, it should be mass of both water and bottle minus mass of empty bottle. So 20 minus 8 grams. Here what do we get? Okay, so we get 12 grams. That is the mass of water. Remember, over the density of water. The density of water. So the mass of water, we have 12 grams. Or the density of water, we are told it is 1 grams per cubic centimeter. So here what do we get now? The volume will simply be 12 cubic centimeters. Okay, that's the volume. So here remember we said the volume of the water will equal the volume of the bottle. So you can now say hence the volume of the bottle is equal to 12 cubic centimeters. Okay, 12 cubic centimeters. Then that is the volume of the bottle. So let's look at question C. Okay, we're on question B. So question A answered, question B answered. Now we are on question what? C. Okay. So question C, we are simply going to do this. We're going to say, question C says calculate the density of liquid X. So we know density is equal to mass over volume. Now the mass we want for liquid what? X, and the volume we need for liquid what? X. Okay. So what is the mass of liquid X? So mass of X, liquid X, is simply equal to mass of bottle plus liquid X minus mass of bottle alone. So mass of bottle plus liquid X, you can see there mass of bottle full of liquid X is 25 grams. Okay, minus mass of bottle. Okay, mass of empty bottle is 8. Okay, and what do we get? Okay, so here we get 17. That's the mass. So we're going to say 17 grams. Okay, now the mass of the bottle, since this mass it is full, okay, so it fills up. So if your bottle you calculated it to be 12, so if you fill it up, meaning that is the same volume of this liquid X, it is filled up with liquid X up to 12 cubic centimeters. So we still use 12 cubic centimeters. Okay, and then we find the answer here. Okay, so very simple reasoning that we are simply using in this question paper. Okay, we're just using very simple reasoning. Okay, and here we are going to do 17 divided by 12. Okay, we get 1.42 grams per cubic centimeters. So that was question 1. That was question 1. Okay, I hope we learned something. Okay, that was question 1. Okay, that was the question 1 for this paper. Okay, so now we are on question. Let's do this. We are on question B2. Okay, so question B2 says that shows figure B 2.1 shows the same cone being placed in different positions of position X, Y, and Z on a flat surface. So X is placed tip of the cone resting on the surface, cone B is laying on the surface, and then cone Z, the base of the cone resting on the surface. So we have these positions. First question says define the center of mass. Okay, and here you just need to give a simple definition. Okay, let's write the definition. So center of mass, you can say this is the mass, or you can say this is the point. This is the point on an object where its whole mass appears to act, or where its whole mass is centered on. Same thing. So that's the definition. Then question B, identify the cone in neutral position. So the cone that is neutral position. So neutral position simply means one that is in balance. It is balanced. So the cone that is in balance, you can see it's Z. Okay. So Z is very, very balanced. Okay. So Z is balanced. Okay. That is the answer here. Then C, state two factors that affect the stability of an object. Okay. Two factors. So factor number one, what determines the stability of the object is there are two things. So there's the center of mass, and also the base area. Okay. So center of mass, sometimes they say center of gravity, and also a large base area. Okay. So now how does this affect? So the center of mass, we say that an object that has a lower center of mass, so it should be lower as possible. Center of mass should be lower as possible. Then the object should have a large base area. So this is what these are the two factors that you can talk about, and this ends question C. So this question carried only 4 marks. So you get 1 mark, 1 mark here, 1 mark there, 1 mark there, 1 mark there, and then you are good. You are good to go after that. Okay. So we go to question B3. Okay. So question B3. Question B3 says that figure B 3.1 shows the direction of 4 forces acting on a car whose weight is 8,000 Newton as it travels. Okay, so you can see the diagram there. You've got force B, force A, force C, and force D. Then BA says, okay, let's do this nicely. BA says it says which two forces should be equal for the car to move at constant velocity. Okay, so which two forces must be equal? So now when you look at the diagram, you have force B which is going this direction, and force D going this direction. So if this car, okay, so this is force B and this is force D. So if this car, okay, I'll try to draw it here, just a simple diagram to illustrate what is happening. Okay, so this car, for it to be in constant velocity, meaning the forward force B and the backward force D must be equal. So to answer question A, we simply write which two forces should be equal for the car to move at constant velocity. So the answer is simply, you just write force B and force D. Okay, that is the answer for this question. Okay, then question B now, still on the same. So we had the force up and we had the force down. Okay, so now question B says calculate the mass of the car. Okay, so now remember we are told that we should take gravity as 10 Newton per kg. Okay, and then we were told in question in the previous question we were told that the weight of the car is 8,000 newtons. Okay, we were told to calculate the mass of the car. So very simple and straightforward. We know from the formula that weight is equals to mass times gravity. Okay, if we change the subject of the formula to mass, it's going to be mass is equal to weight over gravity. What have we done? We just divided both sides by g, and you get mass is equal to weight over gravity. So the weight is 8,000 Newton. The gravity is 10 Newton per kg. Okay, so you cancel the Newton there, and what do you get? So here your mass is simply 800 kg. Okay, 800 kg, that is the mass of the car. Okay, so that was question B1. Now we have question B2. Says the resultant force on the car. What will be the resultant force on the car? Okay, so let's look at this car. It's like this. I'm just making a rough sketch. So you have this force here, which is force D. It is 600. So they are given in that table. They are 600 Newton. The force C here is the weight. Okay, the weight is acting downwards at the center here. So force C is 8,000 Newton. And force B, which is there, it's 800 Newton. Then you have force A, which is what? Force B is 1,000 Newton. Force A is 800 Newton. So now the resultant force on the car. Okay, the resultant force that will act on the car. Okay, so we have forces that will cancel each other. So we are going to say the resultant force. So these will cancel each other. Okay, so the resultant force will be force B minus force D. Okay, this is force D here. So force B is actually, what is force B? Is 1,000 Newton. Force D is what? 600 Newton. So when you subtract here, you get 400 what? Newton. So now this force now is the resultant force. Okay, so what does this resultant force tell us? We need to understand what it tells us. This tells us that this force which is acting forward here as 1,000 will be stronger than the force acting backwards here, 600. So it will cancel off this force. Now remember, there is a 600, so meaning the car will move this direction with the 400 Newton, which is the resultant. Okay, so that is the resultant force on the car. Okay, though you can also find the resultant between this one and this one. Okay, so the resultant force here in the vertical direction, the answer we've answered, so here again, what will be the resultant force? So you are going to say resultant force here will be the force acting downwards, C, minus the force acting upwards, A. Okay, and what do you have? You have 8,000, okay, minus 800. Okay, and what does that give us? Okay, 8,000 minus 800, what do we get? So you get 72,000 Newton. So this is the force that will act downward. Okay, but our answer for this question is actually 400 Newton. That's the resultant force. So we go to 3 now. So B3. So now B3 says that we should find the acceleration of the car. Okay, so we find out that the car will move this direction with this resultant force. And the car has a mass of what? What did we calculate? The mass 800. Now we know that force is equals to mass times acceleration. So So we are looking for acceleration, divide by mass, divide by mass. So we say acceleration is simply equal to force over mass, okay? So the force is the resultant force, where the car will move. So the force is actually the resultant force, which is equal to 400 Newton. And the mass is simply 800 kg. And there you get 0.5, okay, 0.5 meters per second squared. Those are the units for acceleration, okay? So that is the answer to this question, okay? And this was question 3, okay? So it's question 3. Now we go to question B, okay? Let's go to question B. Okay, we are on question B4. Question B4 says, figure B 4.1 shows a crane at a construction site raising a steel block of mass 100 kg through a vertical height, okay? So that's the data we have, okay? So I thought that the block has a mass of 100 kg and it has a height of 16 meters, and the time it takes is 20 seconds, okay? We need to know these things. So question B4A says calculate the work done by the crane. The work done by the crane. So work is simply equal to force times what? The distance, okay? So the work done by the crane. So now what is the force? Okay, the force, okay? What is the force and what is the distance? So the distance here will use the height. So the height will be our what? Distance. Now what will be the force? Okay, what will be the force? So the force now is the force that this crane is trying to use to lift this thing up, okay? The force that is actually being overcome, okay? So we are going to convert this weight or this mass to actually what? Weight, to get the force. So we're going to say that weight will be equal to the force, okay? And weight is measured by, we find it using mass times what? Gravity. So the mass is 100 kg and the gravity is 10 Newton per kg, and here you get actually 1000 Newton. So meaning this will be equal to your what? To your force. Okay, we said weight is equal to gravity. So we are going to say force is 1000 Newton. The distance is 16, and here we get 16,000 joules, okay? 16,000 joules, okay? The same as, or we can just say 16, what am I writing? 16 kilojoules, okay? Because kilo means these 3 zeros here. Okay, so that's the answer to this question. So the power developed by the crane, okay? That is question A1. Question A2, the power developed by the crane. We know power is equal to work over time, okay? Work over what? Time. So the work now is what we found here, the work done by the crane, which is 16,000 joules, okay? The time there was actually 20 seconds, okay? This and this can go. So there are 1, there are 8, so it's actually 800 watts, okay? 800 watts, okay? Then the question says, we are on question B now. Given that the power input to the motor is 1000 watts, calculate the efficiency of the crane. So we know that efficiency is equal to power output over power input times 100. Okay, so the PO is the power output and the PI is the power input. Okay, so the power output now, look at this. The power output is the power developed by the crane, which we've calculated here. Okay, so we're going to say efficiency is equal to 800 watts. The power input we are given in the question, we are told it's 1000, so 1000 watts by 100. Okay, so these zeros can go, we cancel also these zeros there, then this 0 and this 0 can go, and here you will simply get 8%. Okay, so that is the efficiency of this crane. Okay, that's the efficiency of the crane. Okay, we're on question B4. Now we go to question B5. Let's look at question B5. Okay, so question B5, we do this, we'll do it from here. So B5, it reads, below is a graph showing the variation of temperature C with time. So that was frozen water. Okay, so question B5A says, what physical change was happening to the water at point labeled A? So that point labeled A there, what physical change was happening? So this was frozen water, and we know frozen water is simply ice. So here is a point where ice is being changed into water, okay, which is liquid. So what do we call this physical state here? Very simple, it's just melting here. Okay, melting. Okay, that is the answer for A. Okay, it is melting. Okay. Then question B. Okay, question B now. In which state is the water at point between A and B? Okay, the point between A and B, the state there, it's liquid. Okay, the state there, it is liquid now, because once it reaches 100 degrees, water will start to change to gas. Then question C, when the temperature starts to rise, the volume initially decreases and then increases. State the reason for this. So as we see, here we have something like this, and then it goes like this. So here it's actually 0, okay, degrees. So now it starts to raise, okay. Here it reaches 100, okay. So as it starts to raise here it is ice, and then here it becomes what? Liquid, okay. So here is ice, and then here it becomes liquid, and then here it is now gas, okay. So now the question says, when the temperature starts to rise, the volume initially decreases and then increases. State the reason for this observation. Okay, so ice is something like this, okay. Ice is something like this. So when you begin to heat ice, okay, you are increasing the temperature. These ice molecules begin to break, and to a point where they need to become liquid like this. Okay, so the question says, when the temperature starts to rise, the volume initially decreases, then it will increase. Okay, so state the reason for this observation. Okay. Okay, so what happens here is that, first of all, ice, when you heat it, it contracts, okay, and this will decrease the volume. This will decrease its volume. Now, since the temperature is increasing and the ice is being changed to liquid, okay, it expands, okay, it expands. So first thing that happens is a contraction, which will decrease the volume, and then it will expand because you've introduced what? Heat. So if you were to write this nicely, you would say, state the reason for this. The first thing you're going to say is that ice will do what? To contract when you heat it. So those ice molecules are being broken down. Now it breaks down as you increase heat, and liquid, the particles are now. So all in all, what you should know is this: in ice, the particles are like this, so packed together. Now once you heat it, the particles, they loosen up, so there will be an increase in volume to leave this space. So you can explain it in many terms. So this is the particles. Now they are packed together. Okay, so it will contract as those particles are now moving away from each other, okay, to create space. So that is actually the answer for this question, question B. Okay. Okay, question B6. Question B6. We were on question what? B4, B5. So now we go to question B6. Okay. So it says the figure B6.1 shows a ray of light traveling from glass to air at an angle. The refractive index is, okay, so let's see what we are given. So refractive index is given by N. It is 1.52, okay, and then we are shown this thing. So the question here says define critical angle. Okay, question A. So a critical angle, we are going to say critical angle, okay, we say this is the angle. Okay, this is the angle. This is the angle of incidence. This is the angle of incidence at which the angle of refraction is 90 degrees. That's the definition. So it's the angle of incidence that will produce an angle of refraction of 90 degrees. So this is the key words you need to master when you're defining the angle, or the critical angle. And this question is just word mark. So calculate critical angle. Okay, calculate the critical angle. So now first, to calculate the critical angle, what we know is that the formula is this one. So the formula here, we use the refractive index formula. So on question B, okay, so refractive index formula is that refractive index is equal to 1 over sine C, and sine C is the critical angle here. So if we make the subject of the formula sine C, we are ending up with sine C is simply equal to 1 over n. Okay, so C here is actually the critical angle. Okay, so now to find C, when we take the sine this side, it becomes sine of inverse 1 over, now what is n? N here, we had already said that n, which is the refractive index, is 1.5 okay. Here we just use a calculator now to find our answer. Okay, and here we get this angle for 1.8 degrees. So this is our critical angle. Okay, very simple. That's our critical angle there. And we move on to the next question. State two conditions for total internal reflection to occur. Okay, so for total internal reflection, what is this total internal reflection and what happens when it occurs? Okay, total internal reflection. So that is question C. So we have total internal reflection. So there are two possibilities. So we're going to give one. So what happens? Okay, so the first condition is that light must be coming, okay, from a denser medium to a less dense. Okay, so the light ray must be coming from a denser medium to a less dense medium. Okay, light must be coming from a denser medium to a less dense medium. Then the other thing, so a denser medium, for example, glass. A less dense, for example, it's going to air. So then the other condition is that the incident angle must be greater than the critical angle. So it must be beyond critical angle. Okay, what we mean is beyond critical angle. These are the two conditions that are required. Okay, the two conditions that are required. Question D. Give one application or use for total internal reflection. Okay, so total internal reflection, it is used in many things. Binoculars, many things. We'll just give one here in the binoculars. Here we use that. Okay, so we have question now. We are on question B7. The diagram shows an AC generator, its main components labeled A and B. Okay. Question A says, write down the names of components A and B. Okay. So A, we all know what those are. The question has guided us. This is an AC generator. An AC generator always has what we call slip rings. Okay. If it's DC generator, it has what we call split rings. Okay, split rings. Okay, split rings. So these are slip rings. And then B, what are those? Those are carbon brushes. Okay, those are carbon brushes. So for those that like to do engineering, you go deep into these things. So write down the names of A and B. We've done. Then B says, state three factors that increase the magnitude of the electromotive force produced by the generator. So how can you increase the electromotive force? How can you increase what we call EMF? And we should state three things. So number one, number two, number three. How can we increase electromotive force? So one thing would be using stronger magnets. Like to keep my answers simple. using stronger magnets. Then we're trying to increase the EMF. Okay, then the other thing here, you can say using more coils, those coils, okay. Some will say increasing the number of turns of the core, okay. You're using more coils, that thing that is passing around it, okay, increasing the number. Then the last one here will be increasing actually the speed of rotation, the speed, increasing the speed. So you know the generator, it moves, okay, so you have to produce motion, so increasing the speed or motion, okay. Once the motion is increased, the EMF will definitely increase, because once you increase the motion, you're increasing the change of flux, of magnetic flux, and then thereby. So these are just the three things that you need to write, keeping it very, very simple so that you are not confused, okay. That was B7. You need to go to B8. B8 is a nice question. Let's do this, okay. We'll put it there. Okay, so we are now on question B8. So B8 figure shows an electric circuit with 5 ohms resistor R connected to a 12 voltage supply. State Ohm's law, okay. I'm sure we all know by this time, all of us, what Ohm's law is, okay. So we're just going to say Ohm's law. These are things you need to know by now that the exam is very near. Ohm's law states that the potential difference across a circuit is directly proportional to the current, okay, directly to the current, provided temperature remains constant. Provided the temperature remains what? Constant. So provided the temperature remains what? Constant, okay. So provided the temperature remains constant, that is Ohm's law, okay. So I didn't write it very nice, but I'm sure you know what I was talking about. So Ohm's law is actually summarized in this formula. In case you ever forget, this is the summary of Ohm's law. This formula, I'm sure I've seen it many times. Calculate the reading of the instruments labeled A and V, okay. So A is used to measure the current, that's an ammeter there, okay. So this is question B, this is question B, okay. So what is the reading there on the current, what's the reading there on the current, okay. So we know that from this formula of Ohm's law, when you make I the subject of the formula, it's going to be current is equals to voltage over what? Resistance, okay. Now there's only one component here, so it will receive that same voltage. So the voltage there is 12 volts. How many ohms is that? That is 5 ohms. And then what is the answer? So it's 2.4. Then V, that's basically the voltage. Now since there's only one resistor there, okay, so it will receive the whole amount of the voltage. It's not going anywhere, so it is 12 volts. That's for VI, that's 12 volts. Now, what is the cost of using resistor R for 6 hours? So we're now finding the cost now, okay? So we're told this is question 2, B, so this was B1, A and VI, we've calculated them. Now, the cost, so time there we're given 6 hours a day, 6 hours a day, so this is per day, and then it's 30 days, so total time will be 6 hours times 30 days. What do we get, and then the cost is that should be 15 ngwe per kilowatt, so in other words 1 kilowatt hour is 15 ngwe, okay? Then we say, what about x kilowatt hour? Okay, we need to find this one, the x, okay? So first let's find the time, so we have 30 30 times 30 multiplied by 6, so 180, so the total time is actually 180 hours, okay? 180 hours. So we need to find, so energy is equals to power times what? Time, okay? That's how we do this one. Energy is equals to power times time. So we need to calculate the power in this question, okay? So the power, we can use the formula, or we can just allow me to do it from here. Power is equals to VI, the voltage is 12 volts, the current is 2.4 amps, so what will be the power? 12 by, okay, so 12 by 2.4, you get 28.8 watts, okay? So this we write 28.8 watts. The time is 180 hours. What do we get? Okay, so we're just going to say 28.8 times 180. Okay, so we get we get 5, these are the units now, 5,184, okay? And these units are in kilowatt hour, okay? Because, oh sorry, we needed first to change this here to found this in watts. Let's change it to kilowatts quickly. That was a mistake that we can make here. Divide by 1000. Okay, so when we divide this by 1000, we should get 0.0288. With these, we need to never use these. This one is in watts, so 0.0288. Okay, so this was not the correct answer. So times 180, we actually get 5.184. This is now kilowatt hour, okay? That's the kilowatt hour. So now we are now going to do this. Let's do it from here. 1 kilowatt hour is equal to 50 ngwe. What about 5.184 kilowatt hour will be equal to x? So x here will simply be, we multiply this by 15, we get 77.76. Okay, so the cost now, the cost of operating this 6 hours per day, it's actually 77.76. That's the what we are given there in the question. Okay, you can go through the question as many times. This was what question B7. Let's see, do we have, okay, this was question B8, sorry. Do you have any other question? Let me just check this question paper. Question B9. says the figure shows radiations P, Q, and R passing through an electric field. Okay, so emission P goes to the positive, emission R goes to the negative, and Q is just continues the straight line. So question A, identify emission P and Q. So emission P, look at where it's going. It went towards the positive. So this can only be what? Beta emission. Because beta emission, if you write it, it's something like this. It has a negative, or sometimes they'll use the electron. So it is negatively charged. So it will be attracted to the positive. Okay. Then Q is not deflected anywhere. So that is none other than gamma radiation. Okay, that is gamma radiation. It is undeflected. It has no charge. Okay, it is simply undeflected. Okay, it doesn't have any charge. Give one use of emission Q. What are the uses of emission Q? Okay, uses of gamma radiation. Okay, what are the uses of gamma? Okay, so the uses of gamma radiation, it is used in medicine. Okay, you can talk of radiotherapy. There are many uses. So that was question B. Then question C, mention two differences between emissions P and R. So P, we've already said it is beta. R goes to the negative side, and this is because it is alpha radiation. Okay, alpha radiation. So what are the differences here? Okay, I'll just do this. You should write them in paragraph form. So beta radiation, this one is negatively charged. You say, wow, alpha radiation is positively charged. Okay, they said 2-1. Okay, so this one you can talk also about the you can also talk about their masses. Okay, you can talk about the mass of beta. Mass is 0. This one mass is what, 4? The proton number here is -1. Proton there, it's 2. Okay, many things that you can talk about. The differences between beta and alpha. Okay, so this is all what we have to learn in this video. Please, if you have any suggestions, you want me to solve a question paper, leave it on the comment section and we'll go through it together like this one. So see you in my next video. I think I will be doing section C of 2023 GCE.